This should look pretty familiar. Remember when we go back to Algebra 1, you guys did some factoring of quadratic trinomials. What's a quadratic trinomial? Well, it's quadratic means it has x squareds in it, right? So in addition to x terms and constants, it's got an x squared term. Trinomial means it's just got 3 terms. It's got one of each. It's got an x squared term, an x term, and a constant. So we can break these up into 2 types. There's the really easy kind, and then there's the kind that are a little bit tougher, okay? The easy kind of quadratic trinomial to factor is the one where a is equal to 1. This is written in standard form, isn't it? Ax squared plus bx plus c. Everybody agree? Okay. And if we wanted to write down those values, looks like a is equal to 1. What's b? 8. Good. And c? 15. There you go. Okay. So when a is equal to 1, it's very simple. All we've got to do, if this thing is going to factor, we know it's going to break apart, if it factors, into a template like this. It's going to break apart into a product of 2 factors. Why 2? Because it's quadratic, right? I know that if this thing breaks apart, the first term of each of these factors has to be an x. Now think why that is. When we factor, it's the opposite of multiplying or expanding, right? So if I've got x and I'm going to have some number here and some number here that's being added or subtracted to each of these, right? If I were to FOIL this out, if I were to go in the other direction, the only way that I'm going to get an x squared is if the first term of this factor and the first term of this factor are both x's, right? Because then when I distribute, I get my x squared. Does that all make sense? So we know it's always, if it factors, and it may not. There are going to be some cases where factoring, or things don't factor, right? And that happens quite a bit. But if it does factor, it's got to look like this. So now the question is, can we find some magic numbers that we can connect to these x's to turn these into factors? Okay, it's a really simple question to answer. If they exist, the magic numbers have to multiply to c, so they're going to multiply to 15, and they have to add to b, so they have to add to 8. Okay, it's just a matter of being familiar with your facts, your math facts, your multiplication tables. And if you're a little rusty, you'll get good at it in a hurry, because when we do factoring, you got to think in terms of math facts. There is one thing we can do to make the job a little bit simpler. Call this the sign game. So think about these 2 statements here. If the magic numbers have to multiply to, and let's write these down here, they have to multiply to positive 15, and they have to add to positive 8. What does that tell you about the signs? Let's take the product first. If they have to multiply to a positive, what does that tell you about the signs of the 2 numbers? Just that one thing. If 2 numbers multiply to a positive, well, they could be both be positive, or, say it again. They have the same sign. They're either both positive or both negative. Agreed? Okay, so that's what the first part says, if they multiply to 15. Now, if they're going to add to positive 8, which one of those 2 things must have been true? If they're adding to a positive, they're both positive, right? So we know right away that we could put plus signs there and there. Now we have to just go find the numbers. So what numbers multiply to 15 and add to 8? 3 and 5? Okay, so we got it. It's that easy. No big deal. How could we check this? Because we're going to be doing a test on this stuff, right? And on the test, I'm not going to give you a time limit. I think in algebra, sometimes it's important not to have time limits on things, because I want you to be able to go a little deeper with your thinking on this stuff. How could you check this and know if you got it right? Yeah, just FOIL it out. If I multiply it all out, I should get this for my answer, right? Okay, questions? Is that ringing a bell? Does that look pretty familiar? Okay, good. Let's try one more of those. So what about this one? A is equal to 1, right? So we know that if this thing factors, it's going to have to look like, it's going to fit this template. We can start there, right? So my magic numbers this time, they would have to multiply to what? Multiply to what? Say it again. Oh, negative 45. There you go. Negative 45. So whatever C is, which in this case is negative 45. So that's the first thing that has to be true. Okay, what does that tell you about the signs of the numbers if they multiply to a negative? Yes, sir. Okay, good. They're opposite signs. Okay, good. So that's useful. Now, if they're going to add to what, by the way? Negative 4. Okay, that can be a little bit useful to us also. If they add to negative 4, then which of the two numbers must have been bigger, the negative or the positive? The negative. How come? You're right. Because that's kind of a dumb question maybe. How do you answer that? Because when you add a negative and a positive, they cancel partially, don't they? And whichever one is bigger, there's a little bit of that left over. For example, if we did something like, let's say, 10 plus negative 7, the answer is 3, right? It's positive because the positive number was bigger. If we do something like negative 5 plus 8, the answer is, oh, sorry, I want to do something different, don't I? I just did one of those. If I do something like negative 8 plus 5, the answer is negative 3, right? Because the negative number was a little bit bigger. How much bigger? 3 bigger, right? That number tells you how much bigger. So we know in this case that the negative number was 4 bigger than the positive. You don't have to do it this way, but I just think it helps to sort of organize, to just be consistent. I always like to put the bigger number first. So we know the bigger one's going to be the negative, smaller one's going to be the positive. And now before we even find the numbers, it helps to know what the signs are going to be. So now what are they going to be? Numbers that multiply to negative 45 and add to negative 4. We know the negative one is bigger. What are they? Negative 9 and positive 5. Okay, we good? So you'll get some practice on those, right? Those are not that big a deal. Okay, it's a little bit tougher though when A is not equal to 1. Okay, now I did some thinking about this, and I'm going to flip around. I'm going to flip around the way I show this to you. If A is not equal to 1, I'm going to skip ahead here, and I'm going to remind you the way you learned it first. Now I'm going to show you another way too. And I don't care which way you use, but the other way I'm showing you, it's not wasted time because it's something we're going to do. It's kind of a sneak peek at what's coming next unit anyway. And I'll explain why I'm doing that here in a little bit. But for now, let's just look at this method. You guys might have called this, did you call bottoms up? Does that sound familiar? Slip and slide? You did one, was it slip and slide? Okay. I know you did one of the two things. For sure you learned one of the two things. Would have been in Algebra 1. Yeah. How many people are pretty convinced they've never heard either one of those words? Really? Well, I bet you. I bet you somewhere in there, everybody, you've probably suppressed this because it wasn't very fun to do. I don't know, maybe. But I think you would have probably seen this at some point. Okay, so here, we're going to call it slip and slide now. That's kind of the new vernacular for this. That's what Mr. Morioka is teaching now, and I always like to do what Mr. Morioka does on this, so it's consistent. So slip and slide, how does this work? So if we're trying to factor something, a trinomial where A is not equal to 1. Well, what do we always do first, by the way? Always try to do first. But before we even try to do anything fancy like this, what's our first step when we're factoring from the other day we talked about? Greatest common factor. We always want to see if we can undistribute something. But we can't here, can we? This term doesn't have any x's to undistribute, and 13 is prime, right? So there's nothing that's going to divide into all those. Nothing to undistribute. So what are the steps then? When we're trying to factor a trinomial where A is not equal to 1 using slip and slide, here are the steps. The first step is we're going to slip A to the end of the trinomial and multiply by c. Okay, so step one then. Here's a, right? We're going to slip that to the end and multiply by c. So that's going to give us, the 6 is gone now. The first term is just going to be a regular x squared plus 13x minus 6 times 28. That's going to be what, negative 168? Okay, good. First step. Next step. Now this becomes an easy trinomial, right? Because now all of a sudden a is equal to 1, so we can do this the way we did previously. We turned this into an easy one. So it's a basic trinomial. So let's play our sign game then. What's this going to equal? This is going to equal, we know we're going to have x's here and here, right? Okay, so now we've got to see if we can find magic numbers. If we can't find magic numbers, by the way, in either this example or these previous examples that we looked at, doesn't factor, right? Then it just doesn't conveniently factor and we can't do it. So we need magic numbers that multiply to what? Negative 168, okay. And they add to what? Add to positive 13. So everybody contemplate that for a second. See if you can tell me what the signs of the numbers are. Okay, what do you think? Negative and a positive. Which one's going to be bigger? The positive. Okay, so we'll put the positive here and the negative there. How about? So now we got to go find these numbers, right? We got to find numbers that multiply to negative 168 and add to 13. So I want to focus on that task for a second because there's a couple ways we can do this. How would we organize our search? Well, one thing we could do is we could just find factors of negative 168, make a list of factors until we find a pair of factors that multiply to or add to 13, sorry, right? And maybe they exist, maybe they don't. So let's make a little table, how about? M will be our first magic number, N will be our second magic number, and then we want to add up the sum of M plus N because we're trying to get 13, right? Okay, well, let's start with, we know that the bigger one is positive. So what if we made that 168 and negative 1? Those are factors that multiply to negative 168, right? Excuse me, what's the sum? 168 plus negative 1. 167. That's way off, isn't it? We're supposed to get 13. That's way off. So we got to work down the list. Okay, so what's next? Well, 168 is divisible by 2. So if I divide that by 2, I get what? 84 and negative 2. If I add those up, I'm getting positive 82. Still way off, but I want you to notice a trend here. Is 168 divisible by 3? How would you know? There's a little trick. You could divide it by 2 again. I want to know could I have a negative? Could I have a 3 in this? Is 168 divisible by 3? There's a trick for knowing if a number is divisible by 3. Have I told you this trick? Okay, this is a good trick. If you add up the digits of a big number, and if the sum of the digits is divisible by 3, then the original number was divisible by 3. That works for 9 too, by the way. Okay. So 1 plus 6 plus 8, yeah, that works, right? That's 15. 15 is divisible by 3, and so I should be able to divide this thing by 3. Well, 3 goes into 16 5 times with 1 left over. It goes into 18 6 times. So I get those numbers, right? Okay. Still, I'm way off, though. 56 plus negative 3 is 53, but you notice a trend here. What's the trend in the sums? Okay, they're going down. The sums are going down, aren't they? They're getting smaller as the magic numbers gradually get closer together. When the magic numbers are very different in size, when they're extreme, then you end up with large sums. When they're more compatible, when they get closer together, you get smaller sums. So that gives us a little bit of a hint here, right? So we don't have to maybe make this entire table. We can start to see that we could maybe jump down a little bit, right? Because we need the numbers to be much closer together so that they don't add up to such big numbers. So let's try something else. Like, what's another number that adds up to 168? Like, what? Like 8 would go into it, wouldn't it? So let's try 8. 8 goes into 16 twice, and it goes into 8 once. So I get 21 times negative 8. Everybody agree? Okay, and that works, doesn't it? So we could skip down a little ways, and that gives us 13. So that's our winner. So those are our magic numbers, 21 and 8. Okay? Questions on that? Does that make sense? How we did that? Okay. All right, so then we get magic number 21, or is our positive one? Negative 8 is our negative one. And so that was step 2. That was kind of a long step there because we had big numbers. It was hard to find those magic numbers, but we did it. So now step 3, we're going to divide both of our factors by the value we slipped over in step A. And what value is that? That we slipped over in step 1. That was just A, right? Our original A was 6. So we're going to divide each of those magic numbers by 6 in step 3. Just ringing a bell? Remember doing this? Did you learn this trick? Okay, and then last step is we're going to reduce the fractions. So 21 over 6 I could reduce to what? 7 over 2, right? I could divide top and the bottom each by 3. 3 goes into 21 7 times. 3 goes into 6 2 times. And what about here? Good. I divide them each by 2. There you go. So I get 4 on the top. I see what you're saying. So 4 over 3, right? And then look what else it tells me to do. It tells me to slide any denominators up next to the variable, if there are any denominators left after reducing the fractions. Well, there are. After reducing the fractions, I'm left with a 2 there, so I slide that up front. And I'm left with a 3 in this factor, so I slide that up front. And my final answer is just 2x plus 7 times 3x minus 4. Okay, that's the process. Okay, let's try that. It looks like a lot. Anytime you explain something for the first time, it always looks like a whole lot of stuff, but it's really not that bad. It's just they're not that big of steps. But let's try it. Let's take another example. Let me pick one that's not such big numbers here, just for a little practice. Everybody get out some scratch paper and just try this once. Let's see, what's a good one here? Let me make one that's not so nasty. Okay, let's try this one. Try that. Okay, I'll put the steps up here for this one. Okay, how can I do that? All right, let's do this. Get to play with my fancy toy here. I like this. So there's your steps. Let's go through these one at a time. Let's see, Josiah, what'd you get for step one? What'd you do? Okay, so then what'd that leave you with? Okay, good. Okay, what next? So now we got to factor this. Let's see, Stella, did you find magic numbers?
Yeah, I got -12 and +2.
Okay, good. So very good. So we know we're going to get a negative and a positive. The negative is bigger, right? Because they multiply to a negative, so they're opposite, and they add to a negative, so the negative is bigger. And you're right, 12 and 2. Okay, I'm going to give everybody just a second to kind of catch their breath on this and think about step 3. What's next? So Aiden, what'd you get for step 3? What'd you do in step 3? There you go. Good. Okay, so step 3, I'm just going to divide each of the magic numbers by A, right? The number that got slipped. Okay, good. So there's our step 3. All right, what about step 4? Step 4, Emma, what'd you get for step 4? Okay. Okay, good. So step 4, then we get x minus 12/8 reduces to 3/2. I divide each by 4, don't I? And here, 2/8, I can divide each by 2 and get 1/4. Very good. And then the very last part, what do we get for the very last part here, Alexis? There you go. Good. So we're going to slide the 2 up front and slide the 4 up front, and we got it. 2x minus 3 times 4x plus 1. Okay? Do another one? Yeah. Okay. Let me make up another one that's not horrible. Okay. Okay, this time I'm not going to put the list of steps up there. See if you can get this without looking at the list of steps. Okay, try that one. I'll give you just a sneak peek here real quick at the steps, though. Take a look at those steps. So you slip a to the end. You factor that simple trinomial. You divide each magic number by a, and then you reduce and slide. Okay? What's that? Yeah, you betcha. Just, you don't even need to write your name. Just go. Yeah. Okay, let's try a few of these steps. Okay, so first step. Madison, what are you going to do first here? Good. Okay, so we're going to take that 10, and we're going to slide it that way, aren't we? So step 1, we're going to get x squared plus 11x minus 60. Okay, so now we got to factor this. So those would have to be x's. What about magic numbers? Can we find magic numbers that multiply to negative 60 and add to 11? Chloe, do you get magic numbers? There you go. Good. So we know they're opposite signs. The positive is bigger. So positive 15 and negative 4. Very good. All right. Step 3. What are we doing with step 3 here? James, what's next? Did I get that wrong? Oh, that's right. I thought so. Yeah. So, no. Okay, that's fine. That's fine. Matthew? Okay. Okay, good. So step 3 then, after we factor the basic trinomial, we're going to divide each of the magic numbers by a, right? The number that we slipped. So we divide each of these by 10, And let's go ahead and reduce. Okay, and so when you reduced, Matthew, you got, good, those 5 goes into both of those, so I get 3 over 2, 2 over 5. Good, we can divide each of those by 2. Okay, and very last step here, Bren, what'd you get for the last step? Good. Okay, so we'll slip the 2 up as a coefficient of x, and we'll slip the 5 up and make it a coefficient of x. And so our final answer just looks like 2x plus 3 times 5x minus 2. Okay, good. All right. How are we feeling on this? Like we're getting this stuff a little bit? Okay. I want to just look at one more bigger example, because I want to focus on the step 2 on finding magic numbers. That can be a little bit tricky sometimes. So I want to show you another approach to this. Is it a huge deal? Well, not really, but it's just another kind of tool you can add to your arsenal. So let's go through the steps here. On this one, I can't factor anything out. There's no GCF. So I'm going to slip the 8 to the end, right? So step 1. Oops. Step 1, I'm going to get x squared plus 54x minus 8 times 45 is 360. Okay, so those are big numbers. Right now, when I try to factor this thing, I know that if it factors, I'm going to get x's there. If I have numbers that multiply to a negative, so they're opposite, and add to a positive, does everybody agree the positive is the bigger of the two? So now I want to find numbers that multiply to negative 360 and add to 54. Okay, well, there's a couple ways I can go about doing this. I could do it by making factors of 360 and finding the factors of 360 that multiply to negative 360 that add to 54. The other way I could do this, I want to just show you this, sometimes this is handy, is I could pick values of m and n that add to 54 until I find numbers. I know that m is going to be positive and n's going to, or that's supposed to be an n, isn't it? N's going to be negative. Until I get numbers that multiply to negative 360, if they exist. That's another way I could go. So what would that be? Give me an example of numbers, a positive and a negative number that add to positive 54. Well, I'll get you started. Like what if I did 56 and negative 2? Does that make sense? But if I multiply those out now, we're going to make another column of m times n. 56 times negative 2 is negative 112. Not nearly big enough, right? Not nearly big enough. So I'm going to have to make those numbers a little bit bigger. What's another example? Give me another set of numbers that an m and an n that are going to add to 54. What do you think, Aiden? 60 and negative 6. Okay, so I could jump down and go 60 and negative 6. Okay, those add to positive 54, don't they? 60 minus 6. If I multiply those out, I got it. So we had to just go down the list a little bit, but that gave me my magic numbers. That's another way. You see the difference there? That's like plan B. Last time we did this, we looked at factors of negative 168 until we found some that added up to B. But we can also sometimes do it this way. Now, this method I showed you here is really only probably useful when you have a positive and a negative. Otherwise, it's pretty hard. Otherwise, you want to just play the factor game like we did before. But we found our magic numbers, positive 60 and negative 6. And now it's no big deal. I'm going to divide each magic number by what, everybody? 8, okay? So we divide by 8. We reduce, right? So if we reduce, what's that give us? X. What goes into 60 and 8? 4 does. Okay, so 4 goes into 60 15 times. 4 goes into 8 twice. 6 and 8, that'd be a 2, wouldn't it? Divides into both. So I get 3 and 4. And then finally, Last step, I'll just slide the denominators up. And I think you guys have got this stuff. So I get the quantity 2x plus 15 times the quantity 4x minus 3. Okay, good? Are we out of here at 10? Yeah. Why don't you guys grab a wipe and get your desks? We'll call her good. Takes a little practice. So next time I'll show you. Now, let me preface this. You guys go ahead and do your thing here. Go ahead and wipe the desk down. Next time I'm going to show you another approach to this, but you don't